Clones are a great feature of Scratch. Any sprite can make copies of itself. A copy is called a clone. I'm going to make a square, give it 2 costumes, and then write a script to create a chessboard made from 64 clones of this square. First up, we want to create the square. I always like to use vector mode because that way we get really clear pictures. And I'll make the grid a little bit bigger. Now I worked out that the square needs to be 40 pixels wide, and each of these little squares is 4 pixels. So square, make sure it's solid, pick a color, count out 5, 1, 2, 3, 4, 5, hold the shift key down, 5 out the other side, and look at that, spot on 40 by 40. Place that down the bottom left hand corner. That's going to be the first square of our chessboard, and to make sure it always starts there, let's do the usual thing. Now it's time to create the 8 clones. That's all it takes. Let's see if it works. Didn't seem to do much, but in fact there are 8 clones here. Trouble is they're one on top of the other, so we can't see them. And there's the square itself. So what we need to do is, after we make the first clone where the square is, we need to move it along 40 before we make the next clone. That's real easy to do. After we make the clone, change it by 40. Terrific. Next we need to make the colors alternate. To do that we make another costume simply by duplicating this one, picking a different color, and there it is. You can see already the square itself has changed that color. To make it work, we of course will have to put in a next costume after we create the clone, and there it is. Now this code here is what produces that row. So if we put that in a repeat loop of 8, we'll get 8 rows. But of course before we do, we'll need to take the square that's making the row, move it back to the start, and also move it up. We do that by splitting the X and Y business. So X has got to be set to -204 and Y has got to be set to -152. We don't need that anymore. So before we make each row, we have to put X back to the start. Before we start the whole thing, we need to set Y to that value. And after we make a row, we will need to change Y by 40 to move up to the next row. So if we put that in a loop of 8 and try it, you can see we're well on the way. You might like to try to figure out how I fix it very, very quickly. That's all I have to do. Now you'll notice that the original sprite is still there, and that doesn't look too good. So all we need to do is put a hide in here, and that will hide it. But of course we need to put a show at the start, otherwise all the clones will be hidden. Now what I like to do is to give each sprite a number, and I'd like to show you how I do that. We make a variable, I'm just going to call it n for number, and we make it for this sprite only. That means that each clone gets its own copy. All we need to do is to set n to 0 to start with, and then change it by 1 just before we make each clone. Don't need to, well, you'll see n changing here. Let's give it a go. And you can see ends up at 64 on the last clone. But how do we know that each clone actually got that number? Well, it's fairly easy to show you that, because if I go here and say when this sprite is clicked, say what your n number is. We don't need that on the screen anymore. So if I just click on, say, this one, which should be number 64, it is. Click on this one, should be number 1, it is. Click on this one, it should be number 8, and it is. Also, each clone knows where it is. Let me demonstrate that for you. If I put the X position there instead of the N, if I ask this clone where it is, minus 204, where this one is, minus 204, and if we ask where this one is, it's much further along, 76. The catch is that there's no way outside of this sprite to access that piece of information. So the way I get around that is by setting up a list for all sprites so everybody can access it, calling it X, and we don't need that anymore. Then after I make each sprite, I say add the X position to X, and we do exactly the same for Y. And you can see the X list has got 64 entries in it, and the Y list has also got 64 entries in it. If we run it again, those 64 entries stay there, and we get 64 new entries, so we've now got 128. So every time we use this program, we're going to keep adding 64. So one of the gotchas is that you have to, before you start, make sure that we delete everything from each of those lists. Those will make sure the lists are empty before we start. So now it all works fine, both at 64. So we don't need to see those lists anymore. Alright, how would you use that particular list? Well, suppose you wanted to move a piece on this chessboard to a particular square. To demonstrate this, I'll need to go and get a new piece. So always go for vector, and I'm going to have one of these buttons. Let's make it a reasonable size. Check that that's reasonable. Yeah, that's alright. Suppose we wanted to move this counter now to square 61, 64, 63, 62, 6, that's what, that one there. This is how I go about doing it. we'll need to set x and we'll need to set y. What we'll need to do is set x to where square number 61 is, and set y to where square number 61 is. To do that, we simply go to the lists and we ask for item number 61 of x, and similarly item number 61 of y, and if I click to make that happen, it works. And all I have to do is change these numbers and it now goes to number 8. And that's basically all I wanted to show you. So I hope you've got a good idea from this tutorial how powerful and useful sprites can be.